Welcome to Databricks Certified Data Engineer. My name is Noah Gift, and I'm going to be your instructor for this course. I have quite a bit of experience with Databricks and data engineering, and I teach this at multiple universities around the world, including some of the top universities. Let's go ahead and get started here. First up in our course introduction, there are 6 sections that we'll cover. The first thing we'll cover is the Databricks Lakehouse platform. So we'll talk about how to use the Lakehouse platform, the architecture, also creating and managing clusters, configuring cluster runtimes, terminating clusters, restarting clusters, filtering the cluster list, all-purpose versus job clusters. And then in course 2, we cover data transformation with Apache Spark. We'll start off with looking at the development environment. So we'll set up IntelliJ for Databricks with Go, also use the Databricks CLI. We'll also use Databricks with RStudio. We'll get into notebooks, how to execute them, share them, also how to use multiple languages like Scala and SQL. And then we'll talk about how repos work as well. Finally, in the last several courses, we'll start to dive into the Delta Lake. So in course 3, we'll get into data management with Delta Lake. This covers efficient data transformation with Spark SQL, using Catalog Explorer, creating tables from files, also querying external data sources, inspecting tables, reliable data pipelines with Delta Lake, ACID transactions, and more. In course 4, we'll get into data pipelines with Delta Live tables. This includes vacuuming and garbage collection, table documentation, automated pipelines with Delta Live tables, Delta Live table components, looking at continuous versus triggered pipelines, configuring the autoloader, also looking at the querying pipeline events, and even an end-to-end example of Delta Live. In course 5, we get towards the end here, which is working with jobs. So we'll talk about orchestrating workloads with jobs, Databricks jobs demos, multitask workflows, task dependencies. Also, we'll talk about dashboards, handling failures, and even configuring retries. Now, with the final course, we dive into the new feature, which is Unity Catalog. Now, Unity Catalog is interesting because it has the ability to give you more granular control over multiple instances of Databricks. And we'll get into unifying data access, talking about catalogs versus metastores, also get into object security, and then we'll get into best practices for catalogs, connections, and even business units. All right, we have a lot to cover. Let's go ahead and get started.
Let's take a look at the evolution of data architectures. First, here on the left, we see that there's a progression from the data warehouse to the data lake to the lakehouse. One of the reasons for this is that there are limitations of traditional data warehouses for unstructured data at scale, and some of the promises of data lakes didn't fully materialize due to lack of governance. So first, let's define what a lakehouse is. It's a way to combine the strengths of a data warehouse, and you can see some of the things you can do like BI, reports, ETL. It's combining those strengths with the data lake in a new architecture. And again, if we look at the data lake here, you can see that some of the differences are that you can also do data science, machine learning, work with structured, semi-structured, and unstructured data, but it enables the governance, the quality, the performance for analytics, alongside the flexibility for ML and AI. And it's also powered by separating the storage and the compute like the traditional cloud data warehouse. Some of the key attributes include the support for ACID transactions and schema enforcement like you would get with a traditional SQL solution, and also open formats built on low-cost object storage. So in the case of AWS, it would be something like AWS S3. Unified batch, streaming, SQL, and machine learning workloads are also included, and also the ability to have enterprise capabilities like security, access control, auditing, all things that are very important for compliance and for proper data governance. So some of the benefits over past systems include radically simplified architecture for multiple specialized systems, faster time to insight without copying or moving the data, and cost savings of operationalizing one system's infrastructure, and also the flexibility for diverse analytics from BI to AI ML. So some of the limitations here for the future outlook would include early in the maturity, so that they may lag some of the old systems' query performance. Also, there could be some issues where you need better support for non-SQL tools and personas. And one of the things to be, really keep in mind when you're thinking about these new solutions is that eventually those gaps are going to close over time while retaining the simplicity and cost benefits that you get from a data lakehouse. So really, a data lakehouse is an evolution of what is currently happening, and this is something you see all throughout the history of innovation with many different technologies. Here we have the general overview of the Databricks architecture. At the top here, you can see that it's structured into a control plane, and this control plane is managed by Databricks, and the compute plane lives in the customer's cloud. In this example, it shows AWS, but it could be in Azure, it could be in GCP, it could be in some other cloud. The control plane, though, is where all of the action takes place, and it handles the backend services like the storage of notebooks and jobs, and the compute plane processes the customer's data and the workloads. The connector integrates the external data for ingestion, and then the data lake stores securely in the customer's cloud storage. So it works on top of things like object storage and compute. In the case of AWS, it would be S3 or EC2. And there's a separation of responsibilities where Databricks manages the control plane service to reduce the customer burden, and the customer maintains the ownership and control of business data. So this is very similar with the shared responsibility model of AWS, where you manage certain parts of the resources and AWS manages others like the physical data center. In this case, though, you're managing these lower level resources, but then Databricks is actually able to orchestrate on top. So the common workflow would be the data is ingested from sources via connectors into the cloud storage like S3. The compute would spin up on demand to process and analyze the data. And then the interactive workloads in notebooks, batch jobs, SQL, all would share the same architecture, and the results would output back to the cloud storage under the customer control. So what this means is that some of the benefits are fully managed control plane that reduces the overhead. The customer cloud account provides security and isolation, and you have flexibility to handle diverse data workloads and pay only for the compute used through serverless offerings. So in a nutshell here, what you really can do with Databricks is manage complex workflows by leveraging that layer on top, and that Databricks control plane has the web application, the notebooks, the jobs and queries, and the cluster management, and it does many things beyond just data engineering, including MLOps.
One of the more important jobs with managing Databricks environment is the compute. Let's take a look here at this compute tab inside of the Databricks interface. You can see there's several different categories of options. First up, we have all-purpose compute here. So this is a place to start if you're going to do things like work with notebooks, for example, do a basic data engineering operations. And you can see here that I've actually got something running, which is called Thrifty right here. So how would I run this? Well, I could go ahead and click this, and it would say confirm, and it would start this cluster. Now, if we want to create one from scratch here, let's go ahead and say create compute, and let's look at the options. Here you can see that I'm using an unrestricted policy. So this is a new feature of Databricks that lets you control what are the things that a user is allowed to do. That's really the purpose of a policy here. And if we go over to the documentation, you can see here what are compute policies. They can do things like limit users to creating clusters with prescribed settings. So for example, let's say your company has a limited amount of GPUs. You may want to limit a individual user from using more than the allocated resources your company has. You can also simplify the interface, control costs, etc., and even enforce certain libraries. Maybe you want the people in your organization to only use the libraries that you've created. So it's some nice options for control. Now, if we go back to the access mode as well, you can see there's multi-node or single node. Basically, the entire purpose of Databricks is to do cluster compute. So in many scenarios, you would want multi-node. Single node is for prototyping. So if you toggle to single node, you can see it'll just spin up one machines. But the advantage of multi-node is to be able to scale out the disk I/O and the compute for the Hadoop file system, HDFS, and you're going to get that by using a multi-node setup. Now, look at the default runtime here as well. This is important to stay and look at, is that the runtime here is already configured for you, and it has the latest versions of Scala and Spark, and you can toggle it up and down if you want based on the kinds of things you're doing. So generally for regular types of notebook operations, running SQL queries, you would want this standard runtime, and it's going to be configured for you. If you want to do advanced ML operations, notice here that there'll be options for GPU. There could be different versions of Spark, and also the libraries are going to be pre-configured for you so that you don't have to actually select something that's going to be installed. It's already installed for you for many of the standard use cases. So really the runtime is great to allow you to toggle between standard, classic data engineering problems or ML, and the right libraries will basically be automatically configured for you. We also can see here that you can scale up the minimum workers or the max workers. So the defaults here are probably good to use, but if you know you have, let's say, a lot of capacity that needs to be used because you have large data sets, maybe you want to toggle up the minimum workers. So you always use, let's say, 4 minimum workers, and you could also potentially toggle up much larger the max workers, right? And these will all be things that you'll be able to get feedback on according to the resources that are available from your cloud provider. We also can look at the driver type here as well. In this case, we'd want to do the same as the worker. And then in terms of the auto scaling here, this is the button that's going to allow you, right, to use that min and max. Now, this is another very important setting as well, which is, are you going to terminate after a period of time? So for doing lots of ad hoc demos and exploration, this is really going to be something you'd want to have enabled. Now, on the other hand, if you're running something that's a 24/7 cluster, you should turn this off because you don't want to terminate if it's inactive, because it could cause some downtime for other users that are trying to do things. So this is really going to be dependent on your environment. You could also add tags here as well. Let's say you want to say, maybe the team would be data science, right? If you wanted to add some kind of a tag that would tell you exactly what's happening. Now, once this thing is running, again, if we go back to compute here, you can actually look at it and look at the details of exactly what's happening. You could look at the notebooks associated with it, the libraries that are associated with it, install new libraries. You can also look at the Spark user interface as well and look at the different things that are happening with the jobs. You can look at the metrics. This is also very important when you're running jobs, is to see, do I need to have, let's say, a larger scale characteristics? Maybe I need some additional max nodes because I'm overloading CPU, or I'm overloading, disk I/O or memory, etc. You can view all of that from here. So really the compute interface here is a one-stop shop here to manage everything you need to do for basic computation. There also is the compute jobs here, which allows you to do ad hoc jobs and manage those jobs. We also have SQL Warehouse, which is another one. We have pools, which can allow you to logically group the tenancies to allocate compute power. You can also dedicate a cluster from an auto scaling pool to a team or a unit. And then finally, this is where you would go in and you could actually create customized policies so that maybe you simplify the ability to launch things or limit the ability to do GPUs. All this is managed directly from the interface inside of Microsoft Azure Databricks or AWS Azure Databricks or whatever platform you're using Databricks on. Here we have Databricks runtimes, and they include things like the data engineering and ML solutions here. And if we see, the reason for this is that you can have different clusters doing different things, and you don't have to spend a lot of time maintaining them. They're managed by Databricks itself. So this is a huge time saver. If we take a look at standard here, this is just general purpose, right? It's for the ETL operations, data pipelines, batch processing. Let's say you want to have a scheduled job that runs at some interval. It often could be using this standard runtime. We also have support for Python. We have support for R. We have support for Scala, for SQL. There also is this Photon runtime as well, which is optimized for huge data volumes and table scans, and it's great for ETL on petabyte size data. And then in terms of machine learning, we have libraries like TensorFlow, we have PyTorch, we have Keras. Also, regular machine learning tasks are handled as well, like things like pandas, for example. That particular API could be available. In terms of the other runtimes for analytics, we also have SQL Analytics, and this is optimized for SQL and business intelligence use cases. And really the difference here is that you can toggle the attributes of languages and libraries, memory, IO, CPU, the query engine, the concurrency limits. These are all things that you can tweak, and you don't have to manage the fine-grained details. Databricks will manage them for you. So if we take a look here at the interface, you can see a real-life example of this where I have an ML cluster running. You can see it's running the ML runtime, so it's differentiated from the regular runtime. And what's nice about this, again, is that I didn't have to go in and install a bunch of libraries myself. They're already pre-installed with many of the things that I would want to use. And I could, if I wanted to create a new compute cluster, I could just go through here, say new compute cluster, and then again, just toggle through the runtime, and you can see standard ML uncategorized. Likewise, if we go back here, you can toggle to SQL runtimes, pools. You have lots of different options here, and it's up to you to figure, do you want 2, 3, 4 different kinds of clusters, an ML cluster, a data cluster, a SQL cluster. You have all those options available to you in the Databricks interface. Here we have a Databricks interface where there is one cluster that's already running. You can see here that there's a couple of notebooks associated with it. We also have a new cluster that's starting here. If I wanted to control this, one of the ways that I could terminate this cluster is by selecting it. And first, you can terminate it by doing nothing, right? If you have this enabled, you can see that terminate after 120 minutes. This is what will happen when the cluster is actually inactive, like you're not doing something to it, it'll automatically terminate. But there's a more explicit way to do it. If you go over to this section here and we click on terminate, you can see it says, are you sure you want to terminate the cluster? Now this will just basically stop the cluster. Notice that there are other controls though as well. If we go here, you could also clone this, you could restart it. Deleting though would be permanently getting rid of the cluster, including the whole configuration. So the difference between a delete and a terminate is that terminate is just telling it to stop. Now there are other ways to terminate as well, and one of the ways you can do this is from a notebook. So if we go to new here, we go to notebook, notice that the ML cluster is selected. You see that it's green, it's running. Now how would I actually terminate this? Well, what I can do is I can actually go over to the ML cluster, and if we select this and hover over it, you can see that I have the ability to actually terminate it right from this interface. So this is one of the more convenient ways. Let's say you're done with a project and you're inside of a notebook, you've saved it, maybe you've committed it to version control. All I have to do to get rid of it is just select terminate, go ahead and say confirm, and this will actually go through the termination phase. And you can see here that this was requested. Here we have several compute clusters that I'm going to make some changes to, and I'm going to start with doing a restart. One of the things that happens sometimes is a compute cluster could be acting in a strange way, or it's overloaded, it's out of memory. And so how do you actually restart it? Well, let's go ahead and take a look at this Thrifty cluster right here. If I take it and I go to this menu right here, I can select restart. Once I select restart, we're able to actually get this thing in a new state. It'll reboot, and all of the memory and everything else that's happening will really change so that I don't have to actually keep those legacy issues. So another way to do the same thing though is we can also go to the notebook, and if I select the notebook from here, if I scroll down, what I can do as well is actually select this cluster here or some other cluster that's associated with it, hover over it, select restart, and we can see that I can do the exact same thing by restarting from the notebook. So there's two ways to restart inside of Databricks. Both of them can be handy if you're experiencing issues. Here we have the compute interface, and there are 3 different clusters. And if you're working with, let's say, hundreds of clusters, you want to be able to filter very quickly on a name or potentially a runtime. And one of the ways you can do this is by this menu here where it says filter compute you have access to. If we go through here and we type in ML, for example, notice that I can actually quickly pull up the name of the cluster. Another easy thing that you may want to do is look at a particular runtime. Let's say that you know that that runtime, for example, the ML runtime, has a particular version. You could go through and just type in right here 14.2, or in the case of another one, 13.3 or 13.2, right? There's nothing. 13.3, we see we have 2. This gives you the ability to quickly toggle if you have hundreds of runtimes, which is very possible in a larger organization. Another thing that is also helpful in really when you're combining with this is that you can pin maybe your favorites as well. So again, if you have 20, 30, 40 different clusters, you can filter, but then you also could potentially save, let's say, the 2 clusters that you use most frequently up here so that by default you always have access to it. Let's take a look at this concept of all-purpose compute, which is things like a general cluster or building ML clusters. And this is one type of compute that works very well for notebooks or for other things you're doing, but there's a different type called a job cluster. Let's go ahead and look at that by going to data engineering job runs. And if we go over here, what we can see is this was a previous run that I did. It was successful. It took about 6 minutes. And so I could see all of my runs here. And it's a great way to really have an interface that I can see where things have been, failing or succeeding, or whether I skipped one. Now, if we go over to create job, you'll see that I can actually dive into what a job cluster is. So by default, you'll get this job cluster. And the idea here is that a job cluster is optimized and dedicated to run production jobs. And so auto scaling is enabled by default to handle the job load, and it's going to terminate automatically after being idle for a set time. So this is really ideal for doing scheduled ETL pipelines and recurring batch processing. The all-purpose clusters are more for interactive general data analysis. So if we went through here and we said test, and I went through and I selected the notebook that I was going to use, here's where we would see the job cluster. And you can see that this job cluster has slightly different characteristics than the all-purpose cluster, right? It has bigger memory, so 126 gigs, 36 cores. And it's also going to delineate by saying here that it's a job cluster, and it's going to say that the existing all-purpose clusters are different than these. So this is just another tool that you have in your toolkit. If you're going to be running batch-based jobs, doing ETL operations, this is a great way to get things going. In this domain, we cover identity and access management for GitHub. This means covering a few of the critical components necessary for administering user and security, as well as the foundational domain knowledge for governance and compliance. So if we think about the first slide here, which is implications of SAML SSO, this means that you need to allow for centralized identification and the management of those identities. There also are pros and cons for an organization versus enterprise rollout. And also, you need to consider the single source of truth for credentials. If we talk through the steps to enable and enforce SAML, some of the things to consider would be the steps for configuring SAML with the GitHub organization, also the process for enforcing SAML organization-wide, and also the best practices for enterprise account enforcement. Next up here, we have requiring two-factor authentication, or 2FA. This means that you're enhancing the security with two-factor authentication. We'll talk about support for various two-factor authentication methods in GitHub Enterprise, as well as the policy considerations and rollout strategy.
Next, we have supported identity providers. This includes the overview of identity providers and what are they supported for on the GitHub Enterprise platform. Also, the integration of GitHub with existing IAM systems. Finally, how to choose the right providers for a particular enterprise. We also dive into identity management, and we talk about how GitHub handles identity internally, also the roles of organizations and teams, the permission models and access control. And then finally, we get into the last two topics here, which the first one is authentication model. This is the basics of OAuth, SAML, and also other security protocols. We also talk about user login and access granting processes, as well as the identity lifecycle for provisioning to offboarding. All right, we have a lot to get started with. Let's go ahead and dive right into the material.
One of the emerging standards here for doing SDK work for data engineers is the Go language. And I'm going to take a look at how to do that inside of this IntelliJ environment. So you can see here, I've got a Databricks certified data engineer project. And inside of here, I'm going to create my Go SDK code for Databricks. So the first thing that I will do is I will actually go ahead and make a new directory called Go Hello. And I'm going to CD into that directory. Now, the first thing that we need to do inside of this directory is type in go mod init sample. And this will create this initial Go module here. And this Go module is going to hold all of the things that we need in terms of dependencies. So the first thing that I will run is the Databricks SDK. So we'll say go mod ed require, and we'll go ahead and load that in. And now you can see here that we've got this new SDK loaded. We also want to go through here and create a new project file as well. So I'll need to go ahead and touch that. So we'll say touch main.go. And this main.go will be empty to start with. But what I'm going to do is just paste in some code and get it running. So this is from the official documentation. You can see we have a function here. And inside the imports, we have a couple of imports. And so inside the main function here is where we're doing all the work. So first up, there is a client that's created. And then this will unpack what's coming back from the client. In this case, it'll be a clusters list. So let's list all of the clusters that are available. And then we'll say if there's an error, right here, go ahead and panic. Otherwise, let's go ahead and print out, do a for loop over all of the clusters that come back from the SDK. So pretty straightforward here. And all we need to do is install all of the missing dependencies. So we'll type in go mod tidy. Perfect. And then we'll go ahead and grab copies of all the packages needed to support builds and tests of packages. So we'll type them in the go mod vendor. So go mod vendor. Great. And now all we need to do is go ahead and get this thing running by typing go run main.go. And this is going to go through here and compile this and run it, and we should see a list of all the clusters. There we go. So pretty straightforward actually to get Go running. There's some great advantages of the Go language. There's strong support for the Databricks SDK as well. So if you want to give somebody in your team a binary that just ships to, let's say, Kubernetes or ships to some serverless platform that talks to Databricks, this is a pretty good solution. One of the cooler things you can do with Databricks is administer it from the CLI. In order to do that on a Mac platform, all you'd have to do is just do a brew install. So here we go. You can see that I run these brew commands, and in this case, it would go through and notice I've already got it installed, so I don't have to install it. So we're ready to go. Now, all I need to do is say which Databricks, and we can see that this has actually been installed. And at the very beginning, you'll want to run the Databricks configure command, and this will actually configure your environment for the workspace that you're wanting to talk to. And this is where you would also configure any kind of authentication as well. So you would create an OAuth token and put it inside of here. So since I've already done that, all I need to do is just dash help here. And we can see there's a bunch of different commands. We can look at the account, we can look at the API, authentication, bundling. We can also do file system related commands. We can synchronize a local directory to a workspace directory. So these are really cool things that are available inside of this. I would say that one of the more interesting things to start with, though, again, we can see there's a ton of things inside of this, would be to work with the cluster. So first up, what I'm going to do is I'm going to type in Databricks clusters, and I can actually say list, and this will show me all of the existing clusters that are available. And if we take a look at these 4 clusters, you can see that all 4 are running in a terminated state. So that means that at one point they were running, and then now the state has been changed to terminated. So this is a great example of if I was going to do some data science work and I wanted to set up a job before I get frustrated because my job is taking a long time, I can notice that, look, the cluster is actually in a terminated state. We need to actually change that. So how would we do this? Pretty straightforward. What I could do is I could just say Databricks clusters, and we could say start, and then I would put in the ID of the cluster that I'd want to run. In this case, we can do the ML cluster. There we go. And if I do this, it'll actually wait for it in foreground mode and give me the ability to see exactly what happens, finding the new nodes, for example, and then it'll finally show back the start state. So this is a great way to administer machines here. Another thing that I'll point out as well is that we could also query for different information. So let's say I had 100 or 1,000 different machines here. Well, what's a little bit confusing is, how do I know which one has the right hardware? For example, let's say I wanted something with a particular hardware capacity, I don't know, GPUs, etc. Well, what we could do is we could run a separate query while that's running in the background. And I could actually, again, go to Databricks clusters list, and we can see, in fact, it's in pending state. Let's actually find out a little bit more information about that. So what I can do is do get. We can put the ID right here, and it will return back a big JSON payload. I don't want that entire payload, so what I'm going to do is I'm going to pipe it into the JQ, which is a JSON query tool, and I'm going to actually query for some pattern. In this case, I'll say node type ID, and what this will do is it'll actually show us, great, this is a standard DS3 V2. That's the kind of hardware that I was looking for. Or, you could obviously do something more silly like do a name. Of course, we already have the name, but you could actually go through here and figure out whatever it is that you wanted to do by querying that JSON payload. So in a nutshell, the CLI is really something that is invaluable for people that are using the Databricks system day in, day out. You can look through the help command, find a bunch of different recipes, and create solutions that allow you to easily administer and start jobs and interact with the Databricks cluster, even if you don't have access to the web interface. Databricks also works with both R and the RStudio environment. You can see here, this is a Databricks SDK for R tutorial, and notice that it's an experimental SDK for now, but the gist of it is that you need to build out inside of your local R environment a Databricks host. So this would be your workspace URL and then your token, which you can get from the Databricks administrative console. Once you've done that and you've gone through and you've created that token, you can actually put it inside of your .r environment files. Obviously, this is something that must not go into version control systems because this would have the personal access token and also the workspace URL. But once you've done that, you'll go through here and install these packages. So you'll say install packages DevTools. library DevTools, and then you'll install it directly from GitHub. Finally, all you need to do is go inside of here and require the Databricks library that you just installed, make a client, and do whatever it is you need to do. So let's go ahead and take a look at how this would work in practice. So if we go over to this environment here, you can see that I have RStudio running. And I also have a script that I'll walk through here. So first up, what we can do is we can see that I did in fact go through here in the R console and say install.packages DevTools. I also did library DevTools, and then I installed directly from GitHub the experimental R SDK. Now, the next thing that we do is I open up inside of here, you say plus, and you go to an R script, and we require that Databricks SDK. The client is actually pretty straightforward. You make an instance of it, and then you figure out some kind of response based on that client. In this case, there's actually a clusters create command. So this is really useful if you're familiar with the R language. You don't have to actually go into the web interface. You can actually create your own cluster. In this case, I'm creating a cluster called my R cluster. I then specify the Spark version that I want to use, and then I also specify the node type. So this is critical because there are many different types of nodes, and you want to select the one that is going to meet your needs. For example, ML jobs or data engineering jobs. Then finally, you can set the auto termination time. 15 minutes is a sensible default. And then again, if you're just getting this thing experimenting, one worker is fine. And then finally, you get the workspace URL, and this will return back in the result. And then finally, at the very end, you say make sure the workspace URL ends with a /, and then the print paste here goes through and it gives what the response is of that command. So in fact, I was able to do that, and I have a cluster running in this environment. And what's nice about that is you can see that it's actually able to set up the host and the worker node. So there's a total of 2 nodes here. And then what I can do is I can verify this by going to the Databricks CLI, which I can use inside of RStudio. So if I type in here Databricks clusters list, we should see that my R cluster, and in fact we do have that my R cluster running. So the R language is also a option for people that are familiar with it. If you're a data science practitioner and you're really living inside of RStudio, you can absolutely administer the Databricks infrastructure remotely from RStudio. Let's take a look here at the Databricks notebook interface. You can see that you can create a new notebook by going to the new section and clicking on the notebook tab. So I've already done that, and I'm going to name this thing Data Science. So it's really common to want to build out a exploratory data analysis workflow, but notice here that by default you have the ability to use SQL, but you could toggle to another language like Python. You could toggle to Scala, to R. It's up to you to decide what it is you want to do. Let's leave the default here for now. And I also want to show you what I would consider a good first step when you're building out a notebook. So first, we have this markdown cell here, and you can see it from the table of contents. Notice that if you put a markdown cell here, and if we double click on it, you can see it is this markdown tag that it will create this hierarchy for us. So for a data science workflow, I would recommend the concept of ingestion first, and then you could do another markdown cell here by just going through here, copying it, pasting it, and just tweaking it, and we can call this EDA. And now if we go back to the table of contents, you can see we have another one. And then if we want to do another cell as well, we can call this, let's say, modeling, if you're going to do some machine learning. And then finally, we could do one more, and we could have a conclusion. Maybe the conclusion is we have a predictive analysis where we show some kind of result. Now, if we go into each of these sections as well, this would be a good spot where you could put in a new cell and do some kind of coding. Now, notice here in the ingestion phase, I was able to run a SQL command.
Well, how did I know how to start to look at the data? Well, if we go over to this section here, you can see this is a workspace where I could look at other notebooks, or I could look at the catalog. And in the catalog, you can actually start off with the sample data sets here. And you can see that there's several sample data sets. This is the New York City taxi data sets here. And if I want to query it, let's go ahead and do it again. I can go to the middle and select this plus. And from here, I can start to query exactly this hierarchy. So we'll say select, and I can get an autocomplete that's pretty nice. And we can say from, again, I'm getting autocomplete. And now I can just follow the naming structure, right? I can say samples dot, and then it'll go through and tell me what is available actually in the samples. And we'll say New York taxi. And then from here, I want to look at the trips, for example. And then from here, we could actually go ahead and say select star from samples. And I could maybe even do like a limit, and we could say limit 10. And at this section, now all I would need to do to run it would do a shift return, and it's going to go through quickly and run this query. What's nice about it is that it also gives me a table that I can scroll through here and look at the different items, even toggle up and down, for example. And what's great about this is that I don't have to do much. I can really interactively play around with the data and move through things very easily. Now, obviously, I can also hide these cells, and this is a good thing to be aware of, is that you can hide these cells. And if I wanted to create new cells, here I would do another, let's say, exploratory data analysis cell, maybe another one for modeling, another one for conclusion. And at the end of this, I can again go back to my hierarchy, and I can click on any of these, and it'll navigate right to that section. So this is what I would call a normal setup for a data science project. Is you create this structure of ingestion, exploratory data analysis, modeling, conclusion. You go through, you query your data sets, potentially by first looking through and making sure you know what data set you're going to use. For example, the stuff you've already uploaded, or using the sample data. When you're at the conclusion of your project, you can go through and, let's say, share that notebook to other people on your team. Here we have Databricks notebooks, and they're very exciting because there are many ways to use them. You can see here are some existing queries that I've got, but another thing I can do is execute the entire thing from the interface. So if I go to run, notice that I don't have to do things cell by cell. I can select run all. When I do run all, it'll run every single notebook. I could also pick a certain cell. So if you're working with big data, for example, you may want to select a subsection so that you don't rerun everything, or you could run everything above, or you could run everything below, or you could run the selected text, or you could even go to the last run cell. So there's a lot of options here as well. Now, another thing that could be very useful to be aware of in terms of execution is you may want to clear all state and run all. So for example, let's say you've been running this notebook over and over again, and maybe you are unclear of actually the order, or something changed. What you could do is basically redo it, clear all the state, run everything again, and you're now in a known good configuration. So there's lots of options here in the run menu. Another option is you can also schedule. So if you go through here and you schedule, you could schedule a job and say, I want this scheduled every single day at some time. A great example of why you'd want to do this would be, let's say, web scraping or some kind of data collection job. Now, you also could send alerts to your personal email address, and you could toggle on start, success, failure, etc. And you could also name this a particular job. So you can also schedule into the future, or even manually run it if you want to toggle through and take a look at it. Finally, another advanced feature here that's worth pointing out is, if we notice here that we've got this select query here, is I can get hints on what to do. And so how would I get some hints on what to type? Well, if you type in a partial selection here, so we'll say select, you're going to get code completion, which is nice. And we can even get from samples, and we can go through here and do this and even do trips. But what we can also do as well is if we do Shift Option Space, it'll actually give you some ideas of some other queries that you may want to run. So this is also a nice way to get some ideas for execution. They may not be exactly what you want. You may have to change it, etc. But it is nice that you can actually go through here and do the Shift Option Space. And here we go. Maybe 100 is the way that we want to actually run this particular query. So there's lots of options here when you're executing cells, not just doing the shift return, which people typically do, but you can go through the run menu, select certain cells, or schedule things into the future. Once you've created a notebook that has everything that you need, one of the things that we can do is go through the notebook and share it with other people on your team. So how would you do this? Well, if we go over to the share icon right here, you can see that it gives you the ability to share with other people on your team. So you can see here that it will pop down some suggested choices, for example, like admins, and you can go through here and give them this sharing link. Now, another thing you can do is control exactly what they can do. So this is very useful for maybe a developer that's working on some big data projects, is that you want, let's say, the data scientist to only view the notebook because they are going to execute the run, but you don't want them to actually change it. Likewise, you can actually go through here and run, and you can actually allow someone to redo the run, for example, because in the case of a view, if you go through here and you were able to just view the results of the notebook, that's good enough maybe for some of the data science tasks that you need to do. But running requires many resources, and it could require a bit of an understanding of what's happening in your organization and the cluster size, etc. So this could be a more privileged thing to do. Likewise, editing would be reserved for very few amount of people that you share this with, because you don't want someone to make a change to the notebook that could cause the notebook to fail in the future, especially if it's like a scheduled job. And then finally, manage. This would be for the highest level of privileges, and this would be the example where you could allow someone potentially to reschedule the job or change the kind of cluster that it runs with. So there's lots of options here when you're thinking about sharing that you can control inside of Databricks. And then finally, you can just copy the link here and paste that link into a chat system like Slack, or email it to somebody and say, hey, can you take a look at this notebook? I'm having some problems. And if you had, for example, edit privileges, they could even edit the notebook for you, send a link back to you and say, hey, I think I fixed it. Here we have a notebook that I'm going to demonstrate the ability to use multiple languages. Now, by default, you can see here that the default is SQL, but there are other languages we can use. We can use Python. We also can use Scala, and we can use R, and even there's a hidden language, which is Bash, which I'll show you how to do as well. So first up here, if we scroll down and we look at a SQL query, you can see that this is obviously a straightforward way to query. Of course, doing a limit on a large data set is a good idea, so that it doesn't take several minutes just to test something out. Now, if we want to go down and run this, I could just go through here and just click on Run Cell, and this will go through here and give us the result, and we can see the result is able to be shown. Next, though, what we can do is move to the Python section. And what we're going to do in this Python section is also be able to run the cells. And so in order to do that, all we need to do here is go ahead and run this. We can see run cell, and notice the difference. We have the Python right here with the % that tells the cell that it's going to be a Python cell. We also have the import pandas as PD. We then go through here and mount the Databricks file system. We then read it in as a CSV, and then we display the first 10 rows. So this works fine for small data sets. If you want to use something larger, you'll need to use the Spark interface. And then if we want to go down here and look at R as well, this is another choice that we have that's available. And what's nice about the R interface here is that we're able to, if we look through the cell here, require the Spark R library. So this binds with Spark, and we're able to also put in the percentage R here to show that this is going to be a cell that will invoke the R language. And then we're going to read the diamonds data set as a Spark data frame. And you can see here that it's all included. So we have diamonds. We're able to source Databricks. We're then going to split the data into a training set and test set. And we're going to exclude the row IDs. And then finally, the pertinent information is actually printed there. So let's go ahead and run that. And we go ahead and we say run cell. We can see it's going through here, running, churning, going through, and we see the output right there, which is nice. Finally, we have Scala. And if we go through here and we take a look at Scala, again, it's a percentage. We can say import org Apache Spark SQL Spark session. A Spark session is then created, and then you can actually pass in a SQL query if you want, and then that turns into a data frame, which you can actually run the show operation on. And you can see as well, we can run this, and it goes through and it runs that and gives us the data. Now, the final thing that I'll mention is this bash example here. And what's nice about this style is that if you use Python cells, Python has the ability to execute shell commands, and we can actually do this with a percentage. So we can say percentage ls, and then notice when we run this, we're able to actually run any type of shell command inside of here. So this is a great way to, maybe do some data processing or run some commands to see where you're at. So you really have the ability to run not only just these 4 languages, but with the Python syntax, you can also do the exclamation point here, ls, to also get access to the shell ecosystem. Once you start using notebooks quite a bit, you're going to want to look into the workspace, which is a way to share different things in your environment with other people and also organize things, and also repos. So first, let's take a look at workspace here. So inside of the workspace, one of the things that we can do is we can actually add a folder. And so this folder could be, for example, some Scala notebooks. You could put them all in a certain directory. And then once you've got those notebooks directory created, you could actually go through and put a notebook there. And we can just say this is called our, Scala test. And then we could change the default language to Scala. And we can just say sure. And then from here, if we're able to go back to that workspace, that you can see that notebook is there as well. And so finally, I could actually share this entire thing with other people by selecting share. That's one way to do things, is you have this local workflow, and there's a lot of benefits to that. On the flip side, a lot of times you will want to get access to version control and actually go through the version control system and version control your notebook. So let's go ahead and take a look at a repo here. So if we go to repos, you can see one is already added. And if I go ahead and I say add folder, you could actually organize them inside of the folder. That's one way to actually change things. Or likewise, if we go into here, we can actually say add, and we can add a repo. Now, in terms of the repo here, you can see this is the URL, and you could put an HTTP URL here. We also could select different providers, from GitHub to Bitbucket to GitLab to Azure DevOps to AWS Code Commit. So we have lots of options here depending on what are the requirements for your organization, and then you would put your name right here. So once you've done that, you can see I have an example here. You get access to everything inside of the notebook, and we could start to version control the work that you're doing so that it's not lost, and you're able to actually share that work via the version control system with other people. You also can directly add inside of here as well. So if you go through here, you can add files, you can add notebooks, you can add folders. So you do have the ability to interface with them. So there are a couple different ways to version control your system with Databricks. You could always download it and add it in, or you could have the direct workspace integration, and you can actually move things from the repos to the workspace and the workspace to the repos. And in general, it's a best practice to do versioning for your Databricks notebooks.
Let's get started with Spark SQL, which is a way to query all of the Databricks file system in SQL. Let's go ahead and take a look first at this catalog here. So if I look at this, you can see here that we've got these catalogs and in fact sample data as well. So we see sample, default, New York Taxi, TP, CH. We can also look at it from another view. If I go to open bottom panel here, it gives me the ability to also interrogate it from a terminal. So if I type in ls dbfs, that would show us what's inside of that Databricks file system. And I also could look at the actual data sets here. So if we say data sets, and if I want to look at, for example, NYC sample, we can see, in fact, that's where that data lives. And I can even CD into it if I wanted to. Just take this last navigation here, put it inside, and then we can see, for example, there is a directory that has JSON. Inside of that, a whole bunch of different files. In fact, I can do this. I can do a DU. And what this will show me is the size of the entire set of sample data. We could also do it individually, and we could see that there's a large, really variety of different sizes here, 70 meg, 105. So this is a good way to just kind of play around, if you want to see what's happening with the local Databricks file system. But we also can query it from SQL, right? So this is our default language here. And if I go inside of this, what I can do is I can actually type in select star, and we can say from, and we can say we want to do the samples, and we'll do the NYC taxi data. And if we look at the trips here, let's go ahead and limit, let's just grab about 1,000 of these files. Now, this is an okay SQL query, but I can use the advanced features here of the notebook to clean it up a little bit, make it look better. So if I go over to this over here, that's going to run it, but I want to select this one right here, which says format SQL. Let's go ahead and run that. There we go. So we have a little bit better of a SQL format now. And then if I run this, what's going to happen is I'm going to get this giant Spark job that runs, and I can even inspect if I want to and see what was going on. But in general, what's nice about this is I'm able to actually look at this data, look at the different views, sort it, for example. And the other thing I can do as well is click on this plus icon, and there's two different modes we can dive into. We can dive into visualization, which is often a good place to start, or even data profile. Let's go ahead and data profile first, so we can find things like, for example, descriptive statistics, which I often first want to do when I'm looking at something. I want to see what's going on in terms of what's happening here. So we can see that the standard deviation of this particular column is a certain value. I can look at the median. Really, in these it doesn't really make sense, but in terms of trip distance here, we can see that the median is 1.63. So that is something that's interesting. And we can look at the skew, really skewed towards extremely short trips. Simultaneously, we can look at the fare amount, a little bit more spread out, still skewed, but we can see the median fare is 9. And then if we look at the pickup zip code or drop-off zip code, right? So we can get a feel for the data by doing a data profile, which is really handy. We also, though, can click on this plus and do a visualization. So let's go ahead and do this visualization as well. And let's start off with something beyond just a bar chart that's a little bit boring. What we could do instead is we could look at a scatter plot or a bubble plot. Let's do a bubble plot. And then we can select what we want to actually do a scatter plot on. So if we go through here, we can say, let's say the trip distance and also the fare amount. Those are kind of exciting. Oh, there we go. So we got a nice little logarithmic relationship, right? It's linear up until you get to here, and it seems like things start to go into a logarithmic curve here. So it may be the fact that once you go to a certain part of the city, potentially it's like a fixed rate or something like that. But in general, we're able to get a good visualization here by taking a look at this. And if I want to as well, I can just say save. And then I'm also able to have this visualization inside of my notebook. So this is a great way to really immediately start adding value in an organization. You can see it's not too hard to use SQL, do some descriptive statistics, get some great visualizations. And obviously, if I go to here, share, I can share that with other people in my organization. The Catalog Explorer in Databricks is a user interface that allows you to browse, search, manage, and organize different data objects like tables, views, dashboards in the Databricks workspace. Some of the things you can do include providing a centralized portal to search, filter, and browse tables, dashboards, and models. And you can also tag objects, and you can manage access permissions, and you can also view the underlying data within tables. So really, it's a great way to play around with your data, I would say, is the easy example. So let's take a look at this Catalog Explorer here. We have samples. And we see that the New York taxi data would be a good one to play with. So if we click on this, notice what happens is that automatically I can tell that these are the columns, and I could even add comments. Let's say I'm working with a team, and for example, we would want to have some very rich commenting like, hey, we need to clean up this data or whatever it is we want to do. Also, I can look at a descriptive sample as well, which is really nice to just get a view of the data without having to write any code. And we can also look at things like the details, where actually is this on disk, which is a great thing to know because I may want to do some other things with it. And then finally, if I wanted to, I can actually do things with this. So this is kind of neat here, this create widget. So if I say create, probably the first place you'd want to start would be to do a query. So if we do a query here, we can say select star from trips. And in fact, it already does a limit 1,000. So maybe I'll just make it easier and I'll say limit 100. And what's nice about this is that I can do a shift return, and then it's going to go ahead and run this query. It's got a built-in limiter here that protects us from, basically taking down the system by always limiting to 1,000. But if we look at this, you can see that return back 100 rows and 385 milliseconds. So this is a very cool feature here. Now remember, we also can do other things. So if I click on this plus, I could immediately go into a visualization as well. And again, I could look at a scatter plot, for example, pick the X, pick up a zip code, or potentially the trip distance, whatever it is I want to play around with. And then I've got this nice little dashboard here as well. So what's really useful about this is that I can keep on building things. So I can potentially build some kind of a filter. And in general, this gives me the ability to have these stored systems attached to the data so that other people that are looking at it might go, oh, okay, great. This is one of the things that we want to take a look at with this particular data set. Now, the other thing that's also kind of a stealth feature here is if we go to one of these things here, like the Hive Metastore, for example, it also gives us the ability to do more things. So, for example, if I type in Catalog Explorer, we can also open this up in a separate window as well. Now, the other thing that is important to be aware of is that we're able to toggle back and forth between the SQL editor and the Catalog Explorer, which is what we saw. So if I go here and I go to the SQL Explorer, right, that gives me this view, but I could always toggle back and go to the Catalog Explorer. And there's really an interaction between the two things. A lot of times you may want to just look at the data, but then when you want to actually change something, you would go back to the Catalog Explorer. Finally, the other thing you can do that's actually very powerful is dive right into the Databricks file system. So for example, if I look at the file store here, one of the things that we can see is that there is some data here that doesn't have a table. So this would be something that later, if I wanted to create the metadata for this, I could go back to this Databricks file system and look at that particular path, create the table inside of the Catalog Explorer, so then I could do queries with it or do visualizations, etc. So Catalog Explorer is really the place to start when you're dealing with metadata on the Databricks file system, and it saves you a lot of time if you set up some automations around the visualizations and also the descriptive statistics, so other people on your team can immediately start to add value. A very common task that is a little bit confusing with Databricks is how do I add data into the Databricks file system manually and then create a table based on it. So for example, if it doesn't show up in the Catalog Explorer here, how do I actually get it to be created? So first up, what we want to do is look at the DBFS. If we take a look at this DBFS here, look, I have some data that actually isn't inside of the Catalog Explorer. So one of the things that we can do is we can actually pop over to the SQL editor right here. And what I can do is I can actually create a new query here that will create the table for us. So what I can do is I can say create table. And if we want to go back to this real quick, let's double check where this path actually lives. So if I go to this, if I click on copy path, notice how it actually tells us DBFS, file store, tables, height, weight, or the Spark API format, which is the one we want. So I'm going to actually use that when I do this query. So I'm going to say create table, and we'll call this one height, weight, and we'll call this 25K, and we'll say using CSV because it's CSV data, and then we'll say options here, and we can put in essentially the path. And so this will be the first path, and then if I do a quote, I can paste that in. Looks good. And then I can do a header equals true so that it will respect the column headers. And that should do it. If we go through here and we take a look at that, it looks pretty good. And I could even save that query, for example, if I wanted to. And that looks pretty good. All right, let's go ahead and run that. And so what this is going to do, it's going to read in that data. And then there we go. We can see that it's able to actually create that table. So what it means is if we go back to the Hive Metastore, we go to default. Aha, there we go. We've got this thing actually created for us. And if I want to, I can actually close this to get it out of the way. And if we just go over here, we collapse this, we can see all of the different names here as well, which is pretty nice. And I could also open this up in the Catalog Explorer independently. So it's basically already